Hi there. Welcome to part 2 of the milling tool creation walkthrough. Previously, we covered the parameters and essentials to creating a basic end mill. In this video, we're going to take that user-generated tool we made and apply a user representation. What is a user representation, you ask? Well, it's additional CAD geometry that we use to represent the tool. But this isn't just a visual upgrade from our basic tools. User reps address a real need when it comes to accurate simulation and toolpath calculation. Not only that, it's an easy process once you have a tool parameter set defined and a model available to replace our procedurally generated tool. Now, when would you use a user representation? Well, there are a couple scenarios that necessitate the use of it. First, maybe you have a tool with geometry that is impossible to create through standard parameters. Sometimes tooling can have features like this neck-down geometry that do not have associated parameters. Our basic end mill lacks this feature, but a user rep can make it possible. User representations also provide accurate cutting simulation. Because we carefully define cutting and non-cutting zones, we can make use of custom tools and yield real toolpath results, collisions, and other interactions you can expect from your custom tool. It's not always necessary, but user representations fill in the gaps where user-generated tools come up short and maintain a virtual twin for your machining environment. Now, number 2, our second scenario is when you have a tool that behaves outside of conventional cutting behavior. Sometimes special tools like probes or brushes interact with material in different ways. Contact between surfaces can be set to no cut or cleaner type, so that the tool can be simulated to touch a part and not cut into the material. To create a user representation, geometry is required. These models should be prepared prior to use by separating bodies for the cutting and non-cutting zones. In addition, axis systems should be created to help assign a body to a workpiece side and a machine side. Placement of the axis systems are critical. They will be used to correctly snap the bodies into position and also serve as the programmable tooltip. Now, typically downloaded models from the tool vendor or OEM already have these things in place. So if you have the models prepped and ready to go, let's get started with creating a user representation. Okay, I'm going to click on the Manage Representations button right here. And from this box, I'll then click Add User Representation. This will then bring us into the menu that will allow us to define the user representation. Now this button will open up the search command. Now if you notice at the top here, I have the two bodies already open in separate tabs. Now you don't have to work this way. You can also just use the search field to find the bodies in your database. Once you have the bodies open and with the command active, I'm going to go ahead and click on the Cut User Representation example right here, and that will select that body for the user representation. Now we're back in this menu and you can see that the body is in view here. I like to show the default representation by clicking on this button here, and that will reveal the positioning of the body to the actual default representation. You want to make sure they match and overlap each other. It's clearly not the case here, so we have to make some adjustments. I'm going to click on this pointer button right here, and then select the axis system that should represent the workpiece side axis. Notice how selecting that axis system then snaps the body into its correct position. And now, just to double check, I check and uncheck the Show Default Representation to show that these two overlap each other. Now I'll confirm the rest of the choices down below. This is definitely the cut portion of the tool, and we would like to use this representation as its static state, and then it will generate its own rotary representation based off of this static model. Now click OK to accept. You can now see that there is a static and rotary representation present within the list. We're going to go back to the Add User Representation to now add the non-cutting portion of the tool. Let's repeat the previous steps, but go to the no-cut model that we have. I'll click on the Show Default to see where it's situated, and then go to the type to make sure we change it to no cut. Now we'll go ahead and click on the machine side axis system. Then I'll show default just to double check the positioning, and it looks like it's overlaid correctly. and then click OK to accept. If I go to the Show portion of this Manage Representation box, you'll be able to see the default representation, which is what was generated when we created the tool through parameters, and then also the rotary representation and static representation based off of the bodies that we added to the user representation. And there you go. You've just made yourself a user representation. Hopefully this will help you with making custom tools. Join us in our next video as we start to take our individual components that we created and put them together into full tool assemblies. Thank you for watching, and I'll see you in the next one.